Hello and welcome back to the Raw Code Academy. Today we are doing the next part of our Limitless Global Reach with BGP course. That means that we're going to be continuing to experiment on the Equinix Metal platform, leveraging their network and BGP support in order to build out some sample applications that are globally available with minimal latency. If you don't understand what that means, I recommend that you go back and check part 1, where I was joined by Jeremy Tanner / Penguin on the internet, where we talked about what BGP is, how it works, and why it's important to build low latency, globally distributed applications. Today, we're going to build on top of the work that we did in the first part, and we'll be repeating some of the first part as well. So you don't have to go back and watch the first part right now. I will cover the essentials as we go, because we still need to spin up some more Equinix Metal devices, enable BGP, and deploy a workload. What we're going to be doing today with that workload is running Core DNS as a DNS server in 3 metros or regions, facilities, whatever you wish to call them, around the world. We'll be using the US, Europe, and Asia, for example. Using BGP, we can broadcast that DNS server with a single IP address, which will be available to anyone via their closest region. This is really cool because it means you can build at the edge platforms. Now, I'm only using 3 metros today. However, there could be as many as you need to handle your customers and keep them happy at the same time. Now, before we dive into the hands-on component of which all these courses are, if you want to work along and do this on your own, there's a link below, rawcode.link/metal. This will take you to the Equinix Metal homepage, where you can sign up and use the code RAWCODE. This code will get you 200 USD in credits to experiment and play with Equinix Metal throughout this course. 200 USD is around anywhere from 100 to 400 hours, depending on what size of hardware you use on their platform. So there is plenty of credits there for you to experiment, have some fun, and learn some cool stuff along the way. That being said, we're going to dive straight over to my screen share. So this course is available, and really a smarter person would have had the link available. Where's my mouse? There we go. Can't even find my mouse. That is a perfect start. So let's pull this window into display. We have the GitHub Academy, the Raw Code Academy GitHub page, available at github.com/rawcodeacademy. There is a repository there called Courses. You will find the Global Reach BGP directory here. This is today's session with the README and some Polymel automation that we'll be taking a look at. And pretty much everything you need to do this on your own. However, I'm going to run through it too. So any hiccups that I get also means that you can see how I fix it, and I get to update the course material. Win-win. If you have any questions throughout today's session, please feel free to drop them straight into the comments, or if you just want to say hello, go for it. I love to say hello. All right. So the start of this workshop is going to feel very similar to part 1, and that we are going to need to provision some Equinix Metal devices. We have our first hello. Hey, Muzz, thanks for joining us. All right. So we're going to spin up some Equinix Metal devices. We're going to configure BGP, and we're going to do this all manually, run and install Core DNS. Of course, I do have the Polymel automation here, so we'll spin that up too, so you can see what this would look like in a fully automated environment. We got a few more hellos. Hey, Rio, thank you for joining us. And Manuel, thank you for saying hello. I appreciate that. Okay, so let's get started. Today, we're going to spin up Core DNS in 3 metros. We're going to see how this works, and then we're going to take a look at some automation to do it. Now, all of this takes a little bit of time. We have to provision some machines, and we have to automate the provision of some machines. They all take about 10 minutes. So I'm going to kick it all off at the start, and then we will run through the rest of today's examples and materials. So the first thing we need to do here is to go to the Equinix Metal console. First, request a global IP that we can use as our BGP advertisement around the world. This will be advertised on all of Equinix Metal's autonomous systems around the internet. If you're not familiar, Equinix has a completely amazing backbone around the internet. So it's a fantastic network to build on. And in fact, they have direct connections to all the major cloud providers too. So worth checking out Equinix Connect and seeing what you can do with that too. But that's not for today's session. So let's spin up some manual machines first. Then we'll kick off the automation. I'm going to click new server. Oh, I have some clustered stuff because I have an episode of clustered tonight. So we'll ignore that. On demand. And we'll make this bigger so you can kind of follow along. And let's see, we're going to kick off our first one in London just because that's where I am. We'll do a C3 medium. We're just going to use Ubuntu. I'm going to use 2204 because it has this wonderful little lightning bolt, which means it's quite fast to provision, which is great. I don't need to change the name of the host name. I'm happy for that to be LD blah, blah, blah. We'll hit deploy. We'll spin up, I'll maybe just do 2 for now, although the automation will spin up more. In fact, manually I'll just do 1 and the automation can spin up the rest. So if we come to the automation, there's a Polymel directory. And here you're going to see the cloud config that I use to automate the entire process of installing and configuring Core DNS, as well as a Polymel program, which I'm using Q for today. So if you're not familiar with Q, oh, I don't have bat on this machine. I have a new machine, which is proven fun. My dot files were not as complete as I was hoping. This Q lang program does everything that we need to do to spin up these servers. We can use Q export to see what that looks like in JSON or even YAML. Oh, I show YAML. How do I set YAML? Oh, out file. Okay. Dash out YAML. There we go. This is what it looks like in YAML. This is what's actually being run by Polymel. We'll go through this in more detail once we've run through the actual example. All I really want to do right now is just spin this up. Oh, my token. All right, let's do this in a nice, safe, and secure fashion. And I'll grab a token from another browser. Too many monitors. I keep losing my mouse. Copy. Oh. Where did I just paste that? Nothing is on screen. I think I'm okay. Okay, so now we should have a password set and we can run Polymel up. What we're going to see here is just going to do our IP block. 3 devices, one in the US, EU, and Asia. We've got IP attachments and BGP sessions for all of these. And we'll hit go. All right, hopefully that just works. Invalid authentication token. Okay, so do I not know how to paste? Ah, I still got all the YAML on my buffer. There we go. Who'd have thought it was the token that stumped me, or copying and pasting? All right, let's let that go. So that should be better now. And I'm feeling confident, so I'm going to go away from here. We'll come back to courses, global reach part 3. Create failed. But only my Tokyo machine. So that's probably just I got the metro wrong, which I really should have double checked it, but I'm not going to worry about that machine right now. We can still work it without. So I'm going to let that spin up just now. We'll pop back over to VS Code and yeah, Rio. Copy and paste is definitely an art that I should invest some time in learning and improving, but not right now because we're busy. Okay, so we have one device. So I've done this bit here, but I actually forgot to reserve myself a global IP. So we're going to come over here. We're going to go to IPs. And we're going to request a new one. You'll see that my automation already has one, but we're going to do one more. Now, you've got a couple of options on Equinix. You've got public IPv4. These are announced or advertised only within metros. Now, because we want globally available IP, which means it can be hit from anywhere in the world and routed accordingly, we need to go for global. It's a little bit more expensive, but again, if you're watching this video and you want a globally distributed service, then it's probably going to be worth it. We just want one. I'm not going to get any more. And then I'm going to submit my request. And if I refresh, oh, there we go. I thought they were the same. They're different. We now have 40.12 as well as our automation, which got 40.10. Okay, let's jump back over here. So we've reserved one. We have deployed a server. So I was supposed to be using Chicago, London, and Sydney. I've deviated slightly from that, but you can use whatever metros you want. What we need to do now is for each of the servers where we want to be able to advertise this BGP address is that we have to go on and configure a piece of software called Bird. Bird is a BGP advertiser. Bird BGP. Here. So it's just open source software that anyone can use. There are other options for advertising BGP addresses, but I'm quite comfortable with Bird, and Equinix Metal provides some network helpers, which you'll see shortly, which actually configure pretty much everything that we need to do today. So we're going to stick with that. So we are going to apt update, apt install Bird, and Python 3. And then we're going to get these network helpers. So what do we need? We need the IP address of our first server. So we can come back to here. Oh, no, I clicked on demand. And this, no, I spun up the medium in London. Yep. This is my automation. So we're going to ignore that for now. And we are now on a machine, so we can do our apt update. Moz says awesome VS Code theme. Thank you. This is base 16 Dark Ocean. I'm quite partial to the base 16 themes. There's a whole bunch of varieties, but the Ocean one I find is quite nice, especially when looking at code. It's really readable, which is awesome. All right, so we've ran an apt update. We now need to install Python pip get bird. I think it's just Python 3 actually. This just takes a moment. These boxes have pretty good internet. And we have a question from Manuel, who asks, do you know if it's possible to bring your own IP to Equinix Metal? You can, actually. You get a couple of options when it comes to IPs and BGP with Equinix Metal. Now, I believe you do need to speak to the support team. Not all of what I'm about to mention is available via the portal. But I know that from the portal, you can bring your own ASN and have Equinix advertise IP addresses to it, which is very, very cool. It does take, they say it's 1 to 2 business days for a response. During my experimentation, it's been much faster, closer to 12 hours. So you can bring your own ASN and can have a password on it, and you can advertise to it from Equinix Metal. Very cool. And if you want to bring your own IP address, you reach out to support, and then they can hook that up and advertise that IP address for you once you've confirmed that it is your IP address to advertise. So yes, you 100% can. All right, so we now have all of that bits of software installed. So now we need to configure our interface. So we have this cat command here, which is going to basically add a new IP address to the loopback device. And we want this here to be our BGP global IP. Why did I get logged out? Root. Oh, strange. Okay, so let's grab that .12 IP address so that we can configure that as required. So we'll just copy this, assuming I know how to copy paste right, and I'll drop this into VS Code here. Make sure I have the right spacing, and we add this to our interfaces file, like so. Oh. Now, I think that error is okay. Yes, it is. Good. So we do have our IP address on the loopback device. This may be an Ubuntu 2204 error. I'm going to ignore it anyway. My testing was all done with 2004, but I decided at the last minute we should probably use the latest and greatest. In fact, my automation still uses 2004, so it's fine. But I'm going to ignore this message. This is, I believe, just superficial. What we really need to see here is that when we run IP adder, we see our address. So I'm happy with that. And so that I don't commit this, we'll put this back. Next, we have to use the Equinix metadata service. So you can curl and get a whole bunch of data from metadata.platformequinix.com, metadata, pipe that to JQ, apt install JQ. And you get all the information about your actual bare metal device. So you'll see that you have information on the hostname, the operating system, the metro and facilities, SSH keys that have access. You have the specification for the machine. So this is the type of CPU, type of drives, the type of NICs. You've got all the storage information, file system, everything that you need to know about this machine, which some of it you can get just by working with the device file system in Linux. But it's all available over an API. And what's really important for us right now is that we need access to the BGP neighbors configuration, which we haven't enabled yet. So if I actually run, my terminal is a bit overzealous for the copy there. If we try and fetch out the BGP neighbor information, we're not going to get anything yet. Now, our automation handles as follows, but the manual approach is that we need to come into our servers, click on our manual device, go to BGP, and I was going to say turn it on, but it does appear to be on. Did that just happen? No. This was the manual. Yep, London, BGP. Let's just do a big refresh. Oh, that is weird. Wonder if I'm very unlucky and there's some issues. Ah, there we go. We're going to turn on BGP for IPv4. Someone knocking at my door. We're going to turn on BGP IV4 for this device. Now, this should be pretty instant. Yep, there we go. We do a curl to the metadata service again, using JQ to pull out the bits that we need. And we'll see that here's the ASN number that we need to advertise to. Here are the IP addresses that we can do that with. And yeah, nothing else particularly important there. So when you're doing this manually, just remember to come here and turn it on for IPv4 and IPv6, depending on what you're doing. Right, next. So we need to run this command, which is pretty much the same. However, what we're doing here is getting the gateway on the management, getting the gateway on the management interface for IPv4. So that we can configure the routes to go through this. And then we can configure the gateway IP for these routes. So we're going to copy this, come to VS Code, and do this. And this is all handled by the automation. If you don't like doing this stuff manually, it's all good. Oops. Oh, I forgot to add the peer addresses. This is why automation is important. So we did this and this. And now if we run IP route, you'll see that we can successfully route traffic to the peers through the public IPv4 address. We'll undo that so I don't commit it and keep going. So now that we have the routes configured to speak to the peers, we can configure and install BERT. Now, you don't need to do any of this manually. The network helpers available at github.com/packethost/network-helpers do everything for you. They speak to the metadata API, they pull out all the peer information, they configure BERT. We'll take a look at the config, and BERT just starts running via systemd, and everything is good. So you'll see here, it spits it out. We've got our static routes configured here. Oh, cool. I guess you don't need to add that manually. Well, we're still going to do it. We add it's got the routes, it's got the neighbor, and it's got the other neighbor. So exactly what we need. We can run a system control status BERT. We can see that it's running, and I'm just going to ignore these little letters. These are superficial as well. Next, we can run a BERT shell to confirm that it is actually working and doing what we want. BERT C. Remove that. And we'll see here that our BGP state is established. This is good. This is what we want. We want BERT to be able to successfully establish and talk to those peers so we can advertise the address. And this is not always instantaneous, but if you need to confirm this even further, you can go to the admin console, and if you hit refresh, yeah, it's not always instantaneous, but updated every 6 hours. Let's try and force it to be update. As we should see that this machine has a learned route. Yeah, okay. We're not going to wait for that, so that's okay. All right, so BGP is now configured on this device and ready to go. Next, what we want to do is actually run Core DNS. Now, you can do the trace route here if you want, but it's just going to confirm the route that you take on your local machine or an Equinix Metal infrastructure back to that IP address. Should be pretty trivial, I would hope. So next, we're going to install Core DNS on this machine, which is just a curl from the GitHub release binary, and then making it available on our path. And then doing that, we have a question from Moz. What advantages does BGP offer over direct routing apart from dynamic routing? So BGP is what makes it possible to advertise one IP address across the entire internet and route it to different machines depending on where the source request comes from. I don't believe it's possible to do this with other technologies. So what this means is, if you think about traditional networking landscape, you have an IP address that maps to one machine. Sure, it can go through some routers and other pieces of kit before it gets there, but it's always one IP address is one machine. BGP makes it, because it works at the AS level, the autonomous system level, that if you come into an autonomous system, it can actually advertise a prefix or an IP address and say, I know how to route this traffic, and all those different autonomous systems can route differently depending on where the source traffic is coming from. Meaning that if you're in Australia, then you're going to be routed to a server in Australia or as close to Australia as you can get. Whereas if you're in Europe or the US, we're going to route you to traffic within Europe and the US, and as minimal hops as possible, reducing that latency to the first byte, because that's how we build truly scalable distributed systems on a global scale. And I don't think it's possible to do this without BGP, although I am happy to be corrected. So that is why we would do this with BGP. Now, the other alternative way to do it, which is not through a single IP address, but just through sharding geographically at the DNS level, which is having DNS servers and edge locations and having them route the traffic and returning different IP addresses depending on where the request comes from. That is not as I don't like it as much. There's definitely more margin for error and DNS caching and a whole bunch of other things that you have to deal with. But it is a route that cloud providers have used. AWS and Route 53 definitely offer this as a feature. But if you have access to BGP, I really struggle to see why you just wouldn't go down the BGP route. So I hope that helps, Moz. If you have any follow-up questions, just drop them in the chat. And a cool comment there from Manuel. Just a reminder to everyone here who's not a network engineer, you want BGP to be established, not active. Good tip. Thank you. Cool. Let's jump back into this. So we've got Core DNS available, but we need to be able to configure it. And I'm going to do this rather chaotically. So let's just, let's do this first. So we're going to create a Core DNS directory and we're going to write a fake domain to it. Of course, you should use real domains, but because of the way the internet works, I can use whatever the hell I want and it will just work because I'm going to be directly sending DNS requests to this BGP address. So what we're doing here is we're using the Core DNS file plugin, which means that you can store all of your DNS records inside of a file and Core DNS will load them, just like Bind and other DNS systems, to be fair. You can hook Core DNS up to like databases if you wanted to build it out that way. But for today, in fact, in general, just as a good rule, I think the file plugin is pretty spot on, especially as you can store all these configurations in Git, sync them onto the machines, run Core DNS, and then set up systemd to do reloads whenever the files changes and pull new changes from Git. So, yeah, good way to do it. Manuel, gotta go. Make sure you watch later. Appreciate the content. Thank you very much. I really do appreciate that. Thank you for joining, and feel free to comment later when you get around to watching the rest of the video. So we're configuring an origin or domain here for yourfirstdomain.com. We're setting up some store records. We can pretty much just ignore these or copy them from the internet, whatever you want. If you want to do it a bit more nicely or properly, feel free. But the only bit I'm really concerned about right now is that we have 2 records on this domain. One of them we're setting up an A record for www, which is always going to resolve to 127.0.0.1, and an IPv6 localhost quad A record, or 4A, AA, I don't know. I'm not sure what the proper terminology is there. However, this is all you need to configure Core DNS to start serving records. Next, we need a core file, which tells it to load this configuration. The core file is the main configuration for Core DNS. What we're saying here is that we're going to run Core DNS in port 153 instead of 53. And this is because if we try and run it on 53, systemd resolve is going to yell at us. So you don't really want systemd to resolve to yell at you. You could stop it. I'll leave that up to you. What I'm saying here is that I'm going to forward all unknown domains to Google's DNS at 8.8.8.8. If you want to use Cloudflare at 1.1.1.1, go for it, or your own preferred service, up to you. Next, we say that any request for yourfirstdomain.com will be loaded from the configuration file that we wrote earlier. Next, I've written a systemd service file that we copy here, which gives us Core DNS handled by systemd. We can run a daemon reload, start Core DNS. Now, if we've done this correctly, we should be able to dig at 127.0.0.1-p153 and say google.com. Maybe not. Is Core DNS running? It is not. All right, guess we're debugging. So, oh, the directory doesn't, the file doesn't exist. Which Core DNS? Interesting. I think there's something wrong with my unit file. Let's fix it. User local ban, Core DNS. Well, this user won't exist. So these two capabilities allow us to bind on ports less than 1024. I mean, it does look all right, actually. In fact, let's try running bin core DNS core file. Oh, and it's -c. Nope, -conf. Okay, that worked. Restart core DNS. Restart. Not having much luck here. All right. Status core DNS. Yeah, I think it was just a user pragma instead of my unit file. So, I mean, that's best practice, but we haven't set up a user, so I'm going to remove it. And we do have it working. If we do a dig, we get it forwarding on and we get an IP address. So this looks good at the moment, but we'll confirm that. Let me jump into the comments. So we got one from Rio. BGP can be fun. I remember someone able to draw a 9cat on the right dashboard by routing traffic differently over time. Bit scary. I'd love to see that. That sounds awesome. Very cool. Oh, you were trying to debug my problem with me, chmod plus x. No, I think the permission was okay. The script that we used to install it did do a chmod anyway. So I think it was just the user. And the question from Moz, does Core DNS support caching? It does. It has a whole bunch of plugins, actually. So if you come here to coredns.io, go to plugins. What we got here, we've got ACLs if you want to control who can request records from particular domains, if you want to load bind files, if you want to work with Azure. Then there's a cache one here. So if we click on that, this will cache records. Yeah, the configuration or how long to cache it for, etc. Those plugins for, yeah, there's lots of stuff here. DNSSEC. Really, I should start experimenting with that. I keep meaning to do that on my domains, but I just haven't got around to it yet. SCD support, GeoIP, if you want to go down that route, gRPC, headers. Yeah, this is just the supported plugins, and then there's the external plugins as well. So yeah, there's lots of cool stuff here. So Core DNS is great. So we tested Google and we've seen that was forwarded on correctly, which is great. Let's try yourfirstdomain.com. And we only set up www as IPv4. So if we do that, we do get this here, although we still, we have fake authority section here. Don't do that in your own configuration. This is just a demo. But we have the 127.0.0 here. So this is working. We have a DNS server that works. I can use our BGP address now instead of doing 127. So I can come here and as you can see, I've tested this on my own machine previously. Our BGP address is similar, but not. I know it's .12 and there's something in the middle. So let's take a look at what that is. BGP. Nope. BGP. It's not completely different IP address this time. Well, not completely, but different. Okay, so we do dig at port, and we hit it, and we get 127 back. So this is from my local machine. This is not within Equinix Metal. And if we actually do a trace route to this, I've obviously got copy on highlight on this new machine. And if we run a trace route, we're going to have to go through. This is a 5G router that I'm on in my office, believe it or not. So we're going to see a whole bunch of failed hops. And I really should have set the retry on failed hops to 1, but now we're going to have to wait for 5 stars on each. But we'll see the route that this takes to the Equinix Metal infrastructure. And of course, we could run this from another machine and see that routed slightly differently if we had more than one server, which is where the automation comes in. So we can take a look at how you take this manual process that I've done, repeat that using Polymel. You could also do this with Terraform and deploy to as many regions as you want. So we'll take a look at how I'm using Q to template out all this YAML and hopefully give you a good idea of how you can do something similar yourself. I'm going to drink this coffee and hope that the stars disappear soon. More stars. So people that aren't aware, the stars on a traceroute, or in fact, do you know how a traceroute works? What it does is that every time you make a request to something on the internet, it goes through something called a hop. Every device that you go past in order to get to your target device is one hop. If those hops respond to an ICMP ping, then we will get information like we see here. If they do not respond to an ICMP ping, it will try it again. And I thought it was 5 times, but it's 3 stars, so it tries 3 times. And the star just means that it didn't respond. So what we'll see here is that when we do get information, things are much faster, which is why a traceroute can be a little bit slow at times. And the way that it works out the devices is also kind of crude, but really, really cool. When you set up any request on your machine to the internet, you set a time to live, which means that every time you go through another device, it will decrement that. And when basically how many hops you're willing to accept to reach or be routed to another device. And what traceroute actually does is set that time to live to 1 so that it gets terminated at the first device and then gets the ping back and then sets it to 2 and then sets it to 3 and then sets it to 4 until you get to the device that correctly identifies as the device that you're trying to reach. Very crude, but it works really, really well. And Rio was talking about MTR as well in the comments. Yeah, definitely very cool too. I don't believe I have MTR available. So. Okay, so there's not really much more to show from the manual perspective. We deployed a metal device. We hooked up BGP via IPv4. We deployed a configured bird, and then we configured Core DNS using the file plugin to specify the domains that we wanted to respond for. We've made requests from the machine itself and from my own machine using the BGP address. We could see the traceroute does get there eventually. I'm not actually sure. This must be a BGP thing. I never actually considered it before. But seeing that IP address multiple times just means that we're being routed through. That is the Equinix metal infrastructure at that point. Now, let's see the automation. So if we pop over here, oh, I think that failed because of that one device that I couldn't spin up, which is just a wrong metro. Oh, there aren't any servers. All right, okay, let's just remove that one. So I'm going to modify the automation and run it again, and then we'll run through the automation as well. Now let's just remove that. Now those devices, the other 2 devices are already spun up, so this should be nice and fast, and we're not going to have to wait too long. Yeah, so now we're just doing attachments and BGP sessions. Okay, so this is a Polymel YAML program. However, I have used a custom compiler, which we can do with Polymel, but I just say instead of, we're not going to provide you YAML straight up. Instead, we have to do some sort of compilation step to get the YAML back out, or JSON. And for that, we're going to use Q export, as I ran on the command line earlier. Q actually allows us to take Q and spit it out in a whole bunch of formats. We can do JSON. I'm sure there's more, but I'm not going to risk it and try and say if TOML is supported. So yeah, this is the Polymel program written in Q. We're using Q because it allows us to encapsulate YAML into like definitions, which can be reused over and over again, and we'll go through that in just a moment. So the first thing I need to do is set some variables. Now we can specify here a project ID. I do include the code in the repository if you want to create the project by yourself. However, waiting for the approval for the global BGP to be enabled on that, again, can take a little bit of time. So that's if you want to go down that route, but you don't have to. Next, we're using cloud config, and here we're just saying that we have these parts. I've not added all the parts. In fact, the scripts are here. I've just not added them to the queue. I'll update that after this session. But the first thing we want to do is bootstrap. There's also setup bird and core DNS. So these are just shell scripts that do everything that we did manually by SSH, but in an automated fashion. So you'll see here we install JQ. We're looking and waiting. So we're on a while loop or an until loop until that BGP information comes through the metadata API. So if it's not there at first, it usually just takes a few seconds. And we also write custom data to some JSON as well. The custom data endpoint is how we pass in the BGP address to the machine, because that is not available over the metadata API. Next, we set up bird, exact same commands, and we pull the global IP address from the custom data using JQ to get a single value. We configure the loopback device. We get the gateway IP address. For each of those peers, we add a root, and then we install bird and use the network helpers. So the exact same commands, almost verbatim, that we ran via SSH. Next, we have the core DNS configuration. Again, it's pretty much the same. We download the binary, we stick it into a directory, we write some configuration, and we set up the systemd unit file, remove the user, and it'll just work. So, well, actually, that's probably not working, and I'm going to have to manually go into those two devices, remove that user, and restart it, but maybe it'll be okay. If we go back to the queue, we have a request for the global IP. So we're not manually looking for a BGP address this time. We're using the Polymel provider and saying, give me a reserved IP block. It has to be a global IPv4. We only need one address, so it's /32. Then we're using something called a core DNS device, which is a definition in queue, which is how we get modularity/reuse. And we configure that definition. So we're saying here, tweak the name of the device to be EU or US, and deploy it to different metros. So this is Dallas in the US, and this is Amsterdam in the EU. And we're just pulling out the resources from that definition into the top level plan. The queue definition itself has the configuration values at the top, where we specify the type that we expect, but nothing else. Then we can define the resources for this definition. So we have a device. Queue supports interpolation. So we're saying pull in the name from here. We spin up an Equinix Metal device. We're using C3 smalls with an older version of Ubuntu, pass in the project ID, the metro. The user data is our cloud config, but it's the rendered version. So we're concatenating all those different scripts together as a multi-part cloud configuration file. And we pass in our global IP so that we have access to that within the cloud in its system, which is important because we need it. Once that device spins up, we do the IP attachment. So we tell Equinix Metal that this device can advertise this IP address, and we create the session. So we just say, hey, we want to enable IPv4 on this device, the same way we did on the interface with the little tick box that had me confused for half a minute. That's it. The Polymel app gives us the devices. We come to the console. We'll see we have one machine here in Dallas. So let's jump onto there. Get my finger. Let's see if Bart is happy first. Oh. It's not happy, which means something went wrong. This is the output from my user data script. You can see it's sleeping, 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 waiting for that BGP information. It has the BGP information. Oh, that's why. Because I am silly. I even mentioned this as I did it, but we need to do all the scripts. So we'll just run these ones manually that are needed. So there's setup bird, and there is 3 core DNS. So let's just run this script. we'll grab this script. I think what we'll do is I'm going to jump onto the other machine and start pasting these scripts in as well. That's the Core DNS one. Whoa. I definitely angered that. And the other server is here. All right, what did I copy incorrectly from here? Oh yeah, because this is a markdown file. No, wait, it shouldn't be. Oh, I've just copied this wrong. That should be that. There's no more of those, is there? No, good. Okay, so that should fix the first device. Okay, we'll do that one by one. Do we have Core DNS? Yes. Do we have our config? Yes. So it's just the unit file. This looks all right. Yeah. Clearly, I'm just struggling with copy and paste again. So let's do a restart Core DNS status Core DNS. That's probably that unit file. System Core DNS. Ah, of course. Thank you, Rio. Rio noticed that mainped will need to be escaped. Good call. Because it's fine in Cloud Init, it's not fine here. And I can just copy it. All right. Save, daemon, reload, restart, Core DNS, status. What? Oh, the origin hasn't been escaped either. I ran into this. I did do some testing. Yeah, this here is going to be wrong. So let's just fix that. This is just stuff that works when it's ran through Cloud Init, but not when I'm pasting it into the terminal because the interpolation works differently. That's what was missing. That actually looks all right. Run it manually. Okay. Restart Core DNS. Hopefully. It must be running well because the port was taken. No. Maybe it was restarting when it did it. Oh wait. Cannot serve DNS 153 is already defined. Computers. This should be the fail. DNS, your first domain. That looks fine. Core fail is probably where there's a bug. Oh. Because by automation appends to the file. Right. Things work when I'm not being very, very stupid. So let's restart Core DNS. The status on this is 100% going to be okay now. Good. We want to be able to run this on the second machine, so we're going to quickly run through the setup bird again. I believe this just worked. There was no errors here. And then we'll be careful with this one. I'm just going to copy the whole thing. and write it to a file and then execute it, and then we don't have to worry about the interpolation. So Moz asked, is it a good idea to replace bind with Core DNS? Depends on your use case. I find it easier to work with Core DNS. I like its plugins. It's what Kubernetes uses, so I feel like my knowledge is a bit more transferable there than my, I have a lot of bind knowledge from the early 2000s, late 2000s, but I think just consolidating on more modern technology, even though bind still works, it's still great. It probably still powers most of the internet. I'm leaning more towards Core DNS these days. All right. So let's just paste this and run this. Oh wait, this is my local. I'm just doing everything wrong. 40C. Yeah, this is a different machine. Well, that's my London machine. Computers are kicking my ass today. All right. So vim.a.sh. What is there? So I got exited from this for reasons. No. Cool. Let's make sure there's no duplication in our core DNS file, in our core file. Looks good. We'll do a daemon reload. We're going to get there. And a core DNS. If we run a status, it's happy. Now, where we are is we have one machine running in Dallas, one machine running in Amsterdam, both handling a DNS for yourfirstdomain.com via a single global IPv4 BGP advertised address. Okay, let's grab that address. And it's the 40.10. And we're on my local machine. Do a dig at -p153google.com. Oh, wrong port. So that uses a forward plugin and pushes me on. Yourfirstdomain.com should be empty, but if we add www, we get the correct record. So this is cool. But where am I going? Well, let's do a trace route. What's the parameters on that to do failed ping 1? Q1. Let's try that. Yeah, cool. So this won't take too long. But hopefully we see this go through some sort of European Amsterdam data center into Equinix Middle. We can use, like we did in part 1 of this course, there's some web interfaces which will give you a kind of better. This trace route actually isn't very useful whatsoever. So let's do trace route web. Maybe. There we go. So we're not really getting any reverse DNS information. Normally, it would show you. However, not a big deal. What we can see here from Frankfurt is we go through some sort of 4511 network. From Amsterdam is 1851. From London is 1851. New York is 198.32. Now, while we don't have reverse DNS lookup to show us, like, maybe this is going through Amsterdam data center, Dallas data center, parts of the US, etc. And the IP addresses are all different. The routes are being different. They are being propagated through the Equinix Metal network. Good. What's BGP Looking Glass do? Is that anything cool? I don't know. There's normally a more visual one, but it doesn't really matter. So that's it for today. This repository, I'll push these updates that we fixed during today's session. I hope this gives people a good understanding of, cementing and building on the knowledge that hopefully we transferred in part one about what BGP is and why it's important, to a more concrete use case where you can run your own DNS servers. Now, you probably, well, you might, but you might not do this with your own public domains. But if you have certain security characteristics or constraints in your organization, running your own private DNS servers using BGP could be a good way to navigate and handle some of those traffic. And we're going to build on this yet again with the next session in this course. Let me pop back over to face mode. Cool. So on the next session, we are actually going to take this up a gear. And okay, what else is really good at the edge in multiple locations? We're going to take a look at deploying a functions as a service or serverless framework in multiple metros across Equinix Metal, so that you can have functions at the edge. Cloudflare workers are amazing. They have this wonderful technology where you can write code that gets run in over 250 locations as close to your customers as possible. This is a really compelling argument for building globally distributed applications. So we're going to take a look at how we can do that using Equinix Metal and some open source software. So we will deploy functions at the edge. We'll use a web system scraper to fire off a bunch of requests from a bunch of different locations. And what we want to be able to see, and what we will see, is that no matter where we send requests, we're going to see very, very good time to first byte and minimal latency across all of those edge locations. But until then, I will see you all soon. If you have any questions, feel free to leave them in the comments below. We'll be back with the third part of this course in 2 weeks. I'm at a conference in London next week, but I will be back the week after, where we'll do and build something fun. So until then, have a great day. I'll see you all soon.